Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. This video has taken me much longer than I'm exhausted. I'm tired. I got day 8. It's 3 in the morning here. I still got to get up and get at 7, but whatever. Day 8, Part 2, the 7-segment search. I don't know why. I think it because I'm tired. Why did this take longer than it needed to? But I found an answer to this problem. Part 2, just Part 2. So for those of you kind of playing at home here, we've got the 7-segment delay or 7-segment display here. And Part 1 was just figuring out how many of the digits, the easy digits, were there in that data set. And for a while, I was like, what the hell is the purpose of this stuff over here? And in Part 2, it caught up to me because I thought I was oversimplifying the problem is what I was doing. Of course I was, because why would they give us data that we don't need, right? But whatever. You do need these kind of things because these are the 10 digits, and we're going to figure out how to get here. And we need to sort everything out. There's a whole ton of stuff going on here. This is a huge problem. This is an amazing. I thought it was it's a very challenging problem. Apparently, it's pretty challenging since many people have not solved it. I'm only like 10,000 or something. What am I at? What is that a frickin' map? What am I at here? I finished it at 11,000th place, which I'm not feeling bad about that. Okay, so what do I do now? Now you can see all this frickin' nonsense. Look at this thing. It is unreadable. Open up the file. Basically, the left-hand side of this guy, we can sort it out. We sort the whole thing out. I guess it really doesn't matter that I sorted it twice, but I sort out every string inside of the thing, and then I sort all the strings by length. Oh, I do need to do that. So I first sort everything, every element coming in from that on the left-hand side. I sort out because A, B, C, D, E is the same as A, C, B, D, E, and things like that. So we want to make sure that we sort everything properly. So we do that, and then we basically join everything together by the length. And I need that because I know that the first element will be the 1, and then the second element will be the which one is it? Let's see. The first element, because it'll have a size of 2 characters, it'll be the 1. Then it'll be the 7 because it'll have a size of 3 characters. Then the 4 will be there because the size will be 4. And so the third element is the 4. And then the next ones, the next 3 are the fivers, the ones that have 5 segments. The next 3 are the ones that have 6 segments. And the final one is the 8 because it's going to have all 7 segments. So all of that is going to be sorted appropriately every single time. And then on the right-hand side, I'm kind of doing the same thing where I'm organizing everything, I'm sorting every string, but I need to keep those strings from being doubly sorted because those are the 4 digits that I'm going to be calculating. So I do that on the left-hand side, I do that on the right-hand side, and I create a list of lists here, and that's how we at least start out this problem. So now I've definitely a step up from just the simplicity of the first part. So then to keep on going here, I got to go, okay, if I have 2 substrings, how many characters, and again, this is me just kind of spitting in the wind here. When I got an answer, I have my solution. If I have 2 strings, how many characters do they have in common? And what are they? So basically, what are the characters that the 2 strings have in common? And that's what I'm doing here. I'm sure there's something, it seems like it would be very simple, something that would be already in Python. I'll probably look it up in the morning, but I'm going to bed soon. I promise this time I'm going to bed soon. So I get an empty string, and I just say for every character in A, if it's in B, add it in, and then we just go, and we're done, return that. And we're going to need that to do everything else here. Okay, so here is the big one. You can see all the code. I have to programmatically, logically figure out which digits are which from each individual line. That was the thing that threw me off for quite a while, was that every individual line is independent of every other line. When it comes to the switches, I didn't read that or whatever, because I was wondering, because I was figuring if I put all of them together, I should get 3 strings. Like if I set up a set of these things, I should get 3. But I was getting like 19 and 17 and 21, all these crazy numbers. And I'm like, what in the world? I should be getting 3 things for each line, or because it should be pretty easy. But it turns out that every line is different. I think that's what upped the difficulty on this quite a bit. So I say, okay, I have my data, and I say for every problem, every individual problem in my data set, let's do this. And this is where things get crazy here. So okay, so I'm okay. I don't necessarily know if I needed to do this, but at the time I set up, here are my 10 elements, basically just a copy of problem 0 or problem the left hand side. I probably could have called it left hand side, but I didn't. And I say, okay, I'm going to set up a dictionary. And this time around I go, okay, whatever like I was saying, the first element is going to be is basically the 1, because it's got whatever that string is. It's a 2-character string. Whatever the next element is, it's got 3 elements in it, or it's a 3 length and it's a 7. This guy here is going to be a 4-length character string, and it's going to map to 4. And this guy here is going to be a 7-length character string, and it's going to map to 8. So those were the givens from the first problem, basically. What are the 1s, the 4s, the 7s, and the 8s, right? Or 1s, 4s. Oh, maybe. Oh, yeah. This is the 1. This is the 4. This is the 7. This is the 8. I know it's a little off, but that's because of the indexing. So now the question is, how do we separate the 5s from all the 5s from each other, and then the 6s from each other, and then how do we figure out which one is which? And that's where the fun begins here. So I said, okay, I know my 1, 4, 7, and 8, and I know that basically the 5s are going to be either a 2, a 3, or a 2, a 3, or a 5. That's what I know. That is the numbers that are going to come out of this. Here's the say 5s goes to the 3, the 2, and the 5. The 2 and then the other ones are the 0s, the 6s, and the 9s. Those are going to be the separations by 6s. Okay, so what do? I have to logically work this out. I'm going to get the 6 first, and what this does is go through my list of 6s and basically says, okay, take whatever string I got and compare that to the one segment guy here, this guy here, this one. Compare what you got, because you either have a 2, a 3, or a 5. Compare it to a 1, and if it comes back, once we get this a couple times here, you'll see where this is coming from here. So if I test that out and I say, okay, where am I going? Oh, I'm sorry. I'm doing the 0, the 6s, or the 9s. Oh boy, I already screwed it up. Whatever. Okay, so for the 6, I'm trying to differentiate the 0 from the 6 from the 9. And if I test whatever it is, whatever element and whatever string is against the 1, what's going to happen is, okay, if it's a 0, the length of this will come back 2. If it's a 6, it'll come back 1, and if it's a 2, it'll be a 9. So what I'm doing here is testing the string against 1, and if the value comes back as a 1 for my little function here that tells me how many characters what characters are identical, that's the differential between the 6 versus the 0 and the 9. That if it comes back a 1, I've got a 6, and I can kick out. I'm kicking out of my loop. I'm deleting the thing from my list, and I'm moving on. And I'm doing the same exact thing for the 3, but a little different here. I'm testing the 3 in the 5s here. I'm testing the 3 against the 1s, and I go, okay, if it comes back 2, then it's a 3. If it comes back 1, it's a 2, and if it comes back 1, it's a 5. But we can't differentiate that, but we definitely know we have the 3, and we can kick out. So at that point, we've got 6 of them, and then what we're left with over here is we have to differentiate between, since we figured out what the 6 was, now we have to differentiate the 0 from the 9. And I differentiated the 9. I differentiated the 9 by testing against the 4. Because if I test whichever one it is against the 4, If it's a 0, it'll come back as 3. It'll be a 3-character string. And if I test against the 9, it'll be a 4-character string. So if I do that work and I find out that it's a 4-character string that comes back, then that character's a 9, delete out, kick out, and then by default I know that the 0, whatever's remaining has to be the 0. And I do the other thing for differentiating between the 2 and the 5. I test out against the 4 again. And I say, okay, test the 2 against the 4. I will get 2. 2 segments are identical. And against a 5, I get 3. So if it comes back as a 2, then it's a 2. Just keep going, kick out, and whatever's left has to be the 5. Oh my God, right? That took a while. I went down a wrong path trying to think I could do the 5s first when I realized the 6 had to, well, at least with the logic I came up with, the 6 had to be solved first, and everything else kind of went from there, because you kind of had to go from here. And then everything else is kind of actually pretty simple here, since it's a map. So I have a grand total that I'm collecting, and I'm collecting every digit from every value separately. And I say, okay, hey, at right-hand side, for every digit, multiply by 10 because I'm trying to figure out a 4-digit number for this. And I say, okay, hey, I called it setup for all the 10 digits, for all the dictionary that goes from the string to the actual number. And I say, okay, based on that string, go in there and get me the number and add it in and keep going, multiply, 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 and then add it into the total, and everybody's happy. And after Brad stops all this nonsense and talking and all these things, where's my here? What happens at the end of the day is I get my solution of 978,171, which is my correct answer for this problem down here. And hopefully this works for you or you're just interested to know how to solve this problem. This was, again, a fun one. Fun meaning 4 hours of sleep and a tired day tomorrow. Hopefully this hopefully this doesn't get this from here. So let's see what else is going on. And again, 11,000th, not too bad. I think it's 9 in the morning in some places. It's 10 in the morning out in Europe. Yeah. They're going to be a little they're able to do this a little differently. Whatever. Good for you guys. Good for you guys that you have you can wake up at 5 and do for a problem like this. Whatever. I'm just going to stop talking. Well, as always, if this doesn't work for you, please let me know, because this is one of the worst lines of code I've ever written in my entire life, especially if it doesn't have a comment. Good luck when I wake up in the morning trying to figure out what that does. Holy moly. But it gets the job done. So thanks for sticking it out with me. Hope you learned something from this. I did. I learned I got to go early and not worry. Have a great night, everybody. A great morning. Take care. See you next time.